Good evening, class. Hopefully the slide that we're starting with looks familiar. That would be a good question to remember for our quiz today. Today we're going to be going over our Course 1 Lesson 1.6. So listen carefully. And Lesson 1.6 is a little bit different than the first 5 lessons we've studied so far in Chapter 1. Namely in that it's a problem-solving lesson. Now we're going to have one problem-solving lesson each chapter, all the way through the year. Every chapter we do, one lesson will be specially designated a problem-solving lesson. Now, problem-solving lessons, you probably think about, and immediately you're probably thinking to yourself, problem-solving. Oh, those are those word problems. I don't like word problems. Okay, and if you feel that way, you are not at all unusual. Most students are not really excited about word problems. But that's not really what problem-solving is about. I want you to think back to those first 2 days of school we had when we did the problem-solving activity that I brought back from Chicago last year. That was problem-solving. That wasn't a word problem. That was an interesting problem. You had to figure out your own questions. You guys had to figure out what you needed to know, how to analyze the problem. You figured out some information. You worked together. In short, you really showed a lot of great 21st century skills of creativity Sorry, a little technical problem there. But yeah, you showed some great skills. You worked together with teamwork. You showed great creativity. You showed resilience when it got a little frustrating and you weren't sure what to do next. Curiosity, all of these things. Now that's problem solving. Now, will problem solving often involve a word problem? Well, yeah, that's where a lot of them come from. But problem solving means a lot more than that. So what I want to do tonight is just really dig into what are some important skills that we really want to keep in mind when we're dealing with problem solving. And we are going to focus a little bit more on the ones that we tend to find in books. So for tonight, at least, I want to talk about problem solving. Word problems that are problem solving. But I don't want you in any way, shape, or form to think that this word problems is all problem solving is about. Okay? So let's go ahead and let's continue. And let's talk about some key concepts that are going to be really throughout all of the problem solving lessons that we'll do throughout the year. Each chapter, like I said, we'll do one. And each chapter will kind of focus in on a different skill. Maybe that skill might be to draw a diagram, or to come up with a method to try, test, and revise. Okay, the method might involve setting up an equation. Okay, and it might involve drawing a picture. These are all ways and methods and skills and tools that we can use for problem solving. But tonight, what I want to talk about is I want to talk about some overarching concepts that really we should apply anytime we're dealing with a problem-solving situation. Okay, so for the ones that we're going to find in textbooks and on tests and quizzes and worksheets, the first and foremost thing that I always want you to do when you encounter a problem-solving kind of problem is I want you to really, really read the question carefully. Now, when I say that, I actually would like you to read the question initially at least 2 times. Okay, so read it once, get an overview, think about it a little bit, and then read it again and get all of the important information out of the question. Okay, once you've done that and you're really sure what the question is, continue thinking about it, and now I want you to work on coming up with a plan. How are you going to approach this problem? What is it you need to do? This is what that whole first day that we started school was about. What was it that you needed to, what were the questions you had? What was the information you needed? How are we going to go about solving the virus problem? Okay, so plan your approach. Okay, and then finally, work through your plan and work out a solution. And then before you move on to the next question, almost as important as the other two, probably even more important, I want you to look back. And instead of reading the question carefully, you've already read it twice, I want you to read it at this point a 3rd time. Okay? And what I want you to do is I want you to stop and think. Okay, did you take the information in the question? Did you use it appropriately? And does your answer make sense? Okay? Now, if you approach every word problem, every problem-solving problem that you see, whether it's a word problem or not, with these 3 components, okay, reading it carefully, really making sure you know what's going on, planning your approach and executing it, and then looking back and rereading the question a third time to make sure your answer makes sense and that you followed everything that you needed to do, I think you're going to find that you're going to be very successful with problem solving. And as we've talked about before, when you're successful with something, it's not so bad, and you start to like it more. All right, so let's go ahead and break down a typical problem. This is one out of your book. If you have it, you might want to open and follow along. But let me just quickly put this up. Here's a problem about the Olympics, and if you're familiar with bobsled or luge, there's another competition that's very similar. It's called skeleton. Okay, and this problem talks about skeleton competitors, and the difference between luge and skeleton is in luge, you're laying on your back, and your feet go first. In skeleton, you're literally going head first. All right, so it's a really fast, exciting event. And below, and it tells us a little bit about this problem. So I read through the question. Skeleton competitors slide head first down an ice track on a metal sled. Sounds kind of crazy to me. The winner has the fastest total time in 2 heats or runs. In the 2002 Winter Olympics, Tristan Gale won the women's skeleton event. How much faster was Gale's total time than Parsley's? Some key information. So let's read the question to ourselves one more time. While we do that, everybody do that. Reread this question, please, off the screen. And I'm going to underline some key pieces of information that stick out to me. The winner has the fastest total time in 2 heats. So down at the bottom here in the chart, we have their time in both Heat 1 and Heat 2. So right away, I've got a strategy of it might be a good idea to come up with a third column of the total time. Okay? Also, what we're basically trying to answer in this question is how much faster was Tristan Gale's time than Leanne Parsley's? In other words, what was the difference between the gold medal and the silver medal? All right. So once you think you've got a pretty good idea on how to attack this, and I think I've already kind of hinted, what we're going to want to do is add together the times for both Tristan and Leanne Parsley. And if we do that, we get 105.11 seconds for Tristan Gale. And for Leanne Parsley, we get 105.21. All right. Now, if you subtract the winner's time, Gale's time, from Parsley's time, you'll see that the difference, okay, we're going to take 105.2, I'll write it where it's a little bit bigger, subtract 105.11, and I think you can probably already jump ahead and see that the winner was 0.1 second, 1/10 of a second separated the gold medal from the silver medal. All right? Now, before we move on, let's do exactly what we talked about. We read the question a couple of times. We came up with a plan, and we executed it. This is a word problem, so we're going to want to make sure that we label that number, 0.10 seconds. All right? But let's ask ourselves, and again, this comes from the book. Look back at what we've done, okay? Look at the information we're given and the question, the problem, and ask ourselves, is our answer reasonable, and did we check our work? So if we look back for a moment, all right, we look at the times, okay, and is this answer reasonable? Well, if you look at the first heat, it looks like Tristan Gale was about 1/100th of a second faster. But if you look at their second run, Tristan's run was about 9/100ths of a second. Well, let's see, 1/100th and 9/100ths of a second. If we put those two together, that's 10/100ths. Well, 10/100ths, let me go ahead and write that down. 0.10, that's the same thing as 0.1, which is 1/10. Okay? So, yeah, I would say that our answer is very reasonable. And sure enough, we did check it. Always, always, always check your answer and your work. And usually what that means is go back and reread the question and make sure that your answer answers what was asked and does make sense. All right, let's not belabor this. If we wanted to continue this problem, we could also do the same thing. We could look at the difference between the silver medal and the bronze medal. Again, once again, backing up to the problem. We could look at the difference between Parsley's time and Coomer's time. So again, we'd have to go ahead and we'd add across this bottom row, and we'd figure out how long Alex Coomer took on her 2 runs, and we could compare again. All right, I think you got the idea. What I really want to stress is that whatever you're dealing with in terms of problem solving, okay, I would really like you to remember these three key concepts. And they're all right in your textbook on page 30. To read the problem carefully, to plan your approach, and also, I'll go ahead and add this, and execute it. Okay, it doesn't do any good to come up with a plan and not follow through and do it. And then look back, read the question a third time, and make sure our answer makes sense. Okay? All right, well, that is what I've got for you tonight for problem solving. Oops, let's get here to the end. So, I'm going to go ahead and wrap things up, and we're going to end with these three words for tonight. That's all, folks. Hope that reminds you of a funny cartoon. All right, I will see you in class tomorrow, and be thinking about problem solving until then. Take care.